Welcome everyone to another lesson. This lesson we will explore exponential and logarithmic functions. Now consider the following graphs. This picture here contains the graph of an exponential function and a logarithmic function. Can you tell which is which? If you guess that this blue graph was your exponential function, you are correct. Because exponential functions, the basic form, they pass through the point 0, 1, and then exponential growth, it will have an asymptote at the x-axis and rises as we go from left to right, but pretty sharply as you go on the right side of the y-axis. If you guess that the logarithmic function was your red graph, you are correct. Because as you see here, the logarithmic function crosses the x-axis at the point 1, 0. There's an asymptote to the left side of the y-axis at the y-axis, just to the right of the y-axis. And as we move from left to right, it rises sharply on the left and then flattens as we go to the right. If you also notice carefully, the exponential function and the logarithm function kind of look like a reflection of each other. And in fact, if you reflect either one of them through the line y equal x, they will be mirror images of each other. When the line y equal x is the mirror line. Let's think about graphing exponential functions. A basic exponential function will look like y is equal to a to the x. And remember that a raised to the 0 is equal to 1. For example, let's graph y is equal to 3 raised to the x. As usual for graphing any function, we can make a table of values, put in values for x, and from those values of x, we calculate values of y. So for y is equal to 3 to the x, when x is equal to 0, y would be equal to 3 to the 0, which is equal to 1. When x is equal to 1, y is equal to 3 to the 1, that is equal to 3. When x is equal to 2, y is equal to 3 to the second power, that is 3 squared, which is equal to 9. When x is equal to 3, y would be equal to 3 to the third power, and that gives you 27. When x is equal to 4, y would be equal to 3 to the fourth power, and that gives you 81. And when x is equal to 5, y will be equal to 3 to the fifth power, that gives you 243. Now we can graph these as coordinate pairs in a graph: 0, 1, 1, 3, 2, 9, 3, 27, so on. And a part of the graph is reflected here, where 0, 1 will be here, 1, 3, 2, 9, and so on. The other ones will be further up. So that's what part of the graph of y is equal to 3 to the x would look like. Now for y is equal to 4 to the x and y is equal to 2 to the x, we would make tables of values in just the same way. So y is equal to 4 to the x if we choose x values of 0, 1, 2, 3. Y values matching that. 4 to the 0 gives 1 when x is 1. 4 to the 1 is 4. When x is 2, 4 to the second power is 16. And when x is 3, 4 to the third power is 64. And again, a part of that graph is shown right here below. Now for y is equal to 2 to the x, making a table of values. When x is equal to 0, y will be equal to 2 to the 0, which is 1. When x is equal to 1, y is equal to 2 to the 1, which is equal to 2. When x is equal to 2, y will be equal to 2 raised to the second power, which is equal to 4. When x is equal to 3, y is equal to 2 to the third power. That is equal to 8. Again, part of this graph is shown here. So pretty much all of that with some additional parts on the negative side. Okay, so that is how we would graph exponential function. Now sometimes you're given a graph and you're asked to find the equation of the exponential function. So if you're given a graph and you're given a couple of points on the graph, we want to use y is equal to a to the x and to find the value of a. Then we're given 2 points here. When x is equal to 2, y is equal to 36. So then y, which is 36, is equal to a to the x, which is a to the 2. So take the square root of both sides. A is equal to 6. That could be 6 or negative 6. But because this is a growth function, we choose a positive, which is 6. So then the equation is y is equal to 6 to the x. So some basic algebra to do here to find the equation if you're ever given a graph. But generally you're given the function, the equation, to find the values and then sketch the graph. Now let us compare logarithm function and exponential function. Now, as we said earlier, if you look at the graph of an exponential and a logarithm function to the same base, they're reflected to the line y equals x to become mirror images of each other. So the inverse of 5 raised to the x is written y is equal to log base 5 of x. So then we are given a log function to graph. In many cases, it is easier to sketch the exponential function first and then find the inverse by switching the x and y values, interchanging the x and y values. So for example, if you're asked to find y is equal to log base 3 of x, it's easier to find, and as we have already found, y is equal to 3 to the x. When x is 0, y is 1. X is 1, y is 3. When x is 2, y is 9, and so on. Interchange those values, because the inverse function will just be the opposite with the coordinates switched. So then if we take the graph of y is equal to 3 to the x, the table for y is equal to 3 to the x, and we interchange the x and y values, we now have x at 1, y is 0 because we flip the 0 and the 1. X at 3, y is 1 because we flip the 1 and the 3 here. And x at 9, y at 2 because we flip the 2 and the 9 here. And when we plot those on the graph now, we add 0, 1 on the original exponential function. It becomes 1, 0 on the log function. And if we take another point, 2, 9 on the exponential function, we now plot 9, 2 for the log function, and then just draw a curve through those points. And that is one easy way of sketching a log function to the same base from its related exponential function. So here's a question. A typical question would be to copy and complete a table. In this case, for an easy function, y is equal to 2 to the x, which we have done earlier on. So we can just fill those in. We're given values of x, 0, 1, 2, 3, 4, 5. We're given some values of y, 2, 4, and 32. We just need to fill those in. And then it asks to use a scale. So you have to know how to use scales. 2 centimeters to represent 1 unit on the x-axis. So you count 2 spaces and mark 1, another 2 spaces and mark 2, and so on the x-axis. 1 centimeter for 2 units. So for 1 space, you're going to put 2 on the y-axis. For 2 spaces, 4, and so on. For 5 spaces, it will be 10. And then to draw the graph of this function. So you're going to put in for the function y equals 2 to the x. After you fill out the table, you make the coordinate points, right, for x between 0 and 5. So notice here the x values are already between 0 and 5, so you don't have to do anything additional. You just make these table values your coordinates, and then you just draw a curve through them. And from your graph, determine the value of x when y is equal to 25 to 2 decimal places. So it says from your graph, you could have used algebra to do this, but they want you to show it on the graph as well, even if you do something else, because it must be seen on the graph. So then, for your table to complete, we're given the x values 0, 1, 2, 3, 4, 5. So we have to fill in the y value at 0, which is 1, because that is 2 to the 0. The y value at 3, which is 8, because that is 2 to the 3rd power. The y value at 4 is 16. That's 2 to the 4th power. So you've completed the table, got your 3 marks for those 3 numbers that you placed in the table. Now let us look at the graph. We need to use the correct scale. Remember, on your x-axis, you need 2 centimeters. So you count 1, 2, and you put 1 unit, and so on. Another 2 for the 2, and another 2 for 3, and then another 2, 4, and then another 2, you go to 5. On the y-axis, 1 step, 1 space, 1 centimeter, represented 2 units as 2, 4, 6, 2, 4, 6, 8, 10. So 5 spaces is 10, 20, then 30, and so on. Now, each of these in between are 2. So then plot your points: 0, 1, 1, 2, 2 to 4, 3 to 8, 4 to 16, and 5 to 32. So this red line here is your graph of y is equal to 2 to the x. Y is equal to 2 to the x. Right, so for a heading, you could put graph of y is equal to 2 to the x. Always have a heading on your graph. And then your y-axis is labeled, your x-axis is also labeled. So the next part of the question asks us to use a graph to determine the value of x when y is equal to 25. So you have to find a y of 35 on your y-axis. Y is equal to, 25. So it's right there. Then draw a horizontal line across to the curve, and then a vertical line down to the x-axis. And if you notice, this is just a little bit past 4.5. It looks like about 4.6. But they want it to 2 decimal places. So you have to make a good educated guess as to what 2 decimal places here would be, and you get 4.65. Now, if you were to work it out algebraically, you would have got something like 4.64 and some numbers afterwards. But 4.65 is a very, very good estimate for this point right here. Thank you very much for watching.